everyone. We are going to move ahead with our next unit today. We're going to move into Unit 11, which is our area unit. Okay, so today's video is going to be on areas of triangles and parallelograms. Now, I'm having you guys write down on a separate sheet of paper your notes. So if at any point in time I go too fast, feel free to pause the video and write your stuff down and then resume. Okay. I also do this in this unit because next year when you go to Mr. Murphy's class, he doesn't give you guided notes like I do. So if we were in the building, you would get a sheet with just diagrams on it, and you would have to write everything down as I do the lecture. So I'm just trying to get you ready and prepared for that type of classroom. Okay, but because we are doing a video, feel free to pause whenever you need to. All right, so we have some area postulates, so make sure you write these things down. We have area congruent postulate, which is if the shapes are congruent, then the areas are congruent. So if I give you two shapes and I tell you that they're congruent, and you know the area of one shape, now you know the area of the other. Okay, if they're congruent, the areas are going to be the same. The next one is the area addition postulate. You can add all areas of the parts and it's going to equal the area of the whole. So let's say I have a crazy shape that is shaped like this. Okay, what this is saying is I can split this up and create shapes within the larger whole. So I have a semicircle and a rectangle and a triangle. If I find the areas, if I find the area of the semicircle, the area of the rectangle, and the area of the triangle, I can add those areas up and it'll give me the area of the whole shape. Okay, so if I give you a funky shape, look for other shapes that you know inside of it, find those areas, and then you can add them up and get the area of the whole shape. So on the next slide, we're going to talk about the formulas for each shape. You probably know some of these already. So I have an area of a rectangle is going to be the base times the height. Okay. So since this is a rectangle, we have 90 degrees. So this would be my height, and this is my base. Area of a parallelogram is exactly the same thing, because remember, a parallelogram is like a rectangle, it's just slanted, so it still has height and it still has base. So it's still going to be base times height. Okay? And we know, so this is a parallelogram, those are parallel, but this is my base. Now I can give you the height in two ways. In some problems I can give you the altitude here, and altitude actually means height. It's the distance between two things. So I can give you the height in that part of the parallelogram, or I can even give you the height outside the parallelogram, but because it's still spanning the top to the bottom, it's still height. So make sure you look for a height in one of those two spots when we do parallelogram. And then the area of a triangle is 1/2 the base times the height. Now in the past, we've done area of a triangle in some of our units. You guys have done pretty good. You forget the 1/2 though, so please don't forget the half. All right? So in this diagram, my base is here. And when I draw in an altitude in a triangle, so remember an altitude is a segment that goes from a vertex to the base and creating a 90-degree angle. The altitude is the height. Think of, when a plane has altitude, it's going up, it's creating a height. In this triangle, it's a little different. I have my base here. Now, a lot of people want to use this length as the height, but that isn't the height because it's slanted. Height has to be created with a 90-degree angle. So I have to go like this, and the length here is the height. So maybe you want to write that down somewhere. Height is created with a this isn't a 90-degree angle here, this segment can't be the height of the triangle. Okay, and we talked about this a couple times throughout the year. When I'm talking about distance, it has to be between two things. It has to have a 90-degree angle if we're really talking about true distance. All right, I believe we have some problems to try next. So for the next slide, go ahead and pause the video and copy down this diagram and everything that you have, and then try it yourself. And then restart the video and see if we got the same thing. So go ahead and pause it. All right, so now that you've tried to find the area of a parallelogram, let's go through it together. Remembering the area of a parallelogram's formula is base times height. Okay. Right here is my base, and because this is 90 degrees, this is my height. Okay, so the area is going to be 12 times 8, which equals 96. And we have to, in this unit, it's very big that we do units. We put some type of unit on there. Now, I didn't give you a unit here. I didn't give you inches or centimeters. So you're going to just use the U to represent units. And I'm doing area, so those units are squared. And again, if you don't have units squared, you don't have inches squared, centimeter squares, whatever it is, if you don't have that square on it, I am going to take a half point off. Because you're telling me a length and not an area. Area is two dimensions, base and height times each other, and when I do two dimensions times each other, it becomes a square. So make sure you have that unit squared. All right, so the next problem we have, go ahead and pause the video, draw the diagram, and try it on your own. So go ahead and pause it. So now that you've done it, tried it on your own, they do tell me that this shape is a parallelogram. Okay, and so we are trying to find the area of this shape. Okay, if it's a parallelogram, its area equals base times height. So we take a look at that shape. I have the base, 35, but I don't have height because this isn't a 90-degree angle. So 25 cannot be my height. I need something that goes from the top of the parallelogram to the bottom, creating 90 degrees. And I have that right here. Okay, it goes from the top to the bottom of the parallelogram, and it has a 90-degree angle, so this is my height. So over here, I'm going to do 35 times my 20, and I get 700 units squared because they didn't give me a measure for that, so I'm going to use units. And it has to be squared because we're doing area. It's two dimensions times each other, which makes it squared. All right. Next problem. Go ahead and write this problem down and pause the video and try it yourself. Go ahead and pause it. So now that you've tried the problem on your own, it says the base of a triangle is half the height. The area of the triangle is 64 squared inches. What is the base and the height? Okay, so first they give me a triangle, so I'm just going to draw some generic triangle. Okay. It says the base of the triangle is half the amount of the height. So remember, height is the altitude, so I'm going to draw that in. If I make that h, the whole base has to be half that amount. So this whole base is going to be half the height. So half times h, half the height. All right. Now, they gave me the area. They told me that the area of the triangle is 64 square inches. So if we remember, the formula for a triangle is A equals 1/2 base times height. Okay. They told me that the area is 64, so my A is 64. All right. And in the problem, if I look at my diagram, I've labeled my base as 1/2 the height. So right here, I'm going to put 1/2 h for the base. And then for the height, I still have an h, so I'm going to put an h there. Okay, so what you have to do in this problem is I give you the area, and I want you to find the base and the height. So we're working backwards. Okay, so you have to use letters to represent the height and the base. You want that letter to be the same because you don't want an equation with two variables. So that's why we wrote the base as 1/2 the height. Okay, and now I have to simplify. So before I start solving, so 1/2 times 1/2, if I multiply these two together, I get 1/4. And h times h is h squared. And I'm trying to solve for h, so I want to get rid of the fraction. Remember, to clear a fraction, we multiply by its reciprocal. Well, the reciprocal of 1/4 is 4/1, 4 and 4. So I'm just going to multiply by 4. And I get 256 equals h squared. And to get rid of the square, I square root both sides. Now we're going to keep it positive, no plus or minus, because we're talking about a length, a height. So I don't need a plus or minus. So then I get that the h equals 16 inches. I know it's inches because they told me right here. And then to find the base, I take half the height, which is 16, and I get 8 inches. So there are my two answers, my height and my base. All right, we have two problems down here, so what I want you to do again is I want you to draw these diagrams down and try them on your own. Keep in mind that we have that area addition postulate. Okay, so go ahead and pause the video and try them on your own. All right, so now that you've tried this on your own, I'm going to start with this first one. Okay, it's a funky shape. It's not a parallelogram and it's not a triangle because right now those are the only two things I know how to find the base of. Oh, and a rectangle. Okay, so what I'm going to do is I'm going to look for some of the shapes I know inside this. So I can create, if I go straight down and make a 90-degree angle here, I have now created a rectangle and a triangle. So if I find the area of the rectangle, and then I find the area of the triangle, I can add the two together to get the area of the whole shape. All right, so area of a rectangle, remember, is base times height, so I need its base. The base of my rectangle is 12. And the height of my rectangle is 6. So when I multiply those together, oh, my bad. My base is not 12. My base is 10 for the rectangle. The 12 is the whole length of the bottom. So it's actually 10. So don't make that mistake like I did. All right, so my rectangle's base is actually just 10. I multiply those together and I get 60. All right, and then the triangle, remember our formula is 1/2 base times height. Okay, well in rectangles, opposite sides are congruent. We learned that from our quadrilaterals unit, so this is 6. So I know the height of my rectangle is 6, but I need this base right here. Okay, if I know from here to here is 10, and I bring that down, from there to there is 10, and the whole is 12, this has to be 2. So I know I have 1/2 the base of 2 times 6 the height. And when I multiply that all together, I get 6. And remember, to find the area of the whole, I just need to add these together. And I get 66, and it's going to be units squared. All right, the next one is an interesting shape. Kind of looks like a star. I have a square in the center, and I have triangles around the edges. I take a look at, let's start with the square, because it's probably going to be the easiest one to do. So let's find the area of the square. Again, it's just base times height. It's like a rectangle. I have that the height is 4. And I know all the sides in the square are equal, so the base is also 4. So I'm going to do 4 times 4, which equals 16. So that takes care of my square's area. But now I need to find the area of the triangles. And what I notice about the triangles is that they are all congruent because they all have side, side, side congruency. Which means if the triangles are congruent, then the areas are congruent. So I only have to find the area of one triangle and just multiply it by 4. All right? And it's 1/2 base times height. So So my base of my triangle is 4, because the square and the triangle share that side. It is the base for the triangle and the square. And then my height is my altitude, which they gave me right here, is 2 square root 3. Now, you are not going to put that square root 3 in the calculator and get a decimal. No decimal answers in this unit either. Okay? At least for now. When we have to add things together, we can give them. Actually, I changed my mind, guys. You can give me decimals. It's totally fine. Just don't give me decimals with pi. All right? Like in the last unit, no decimals with pi. So you can give me a decimal here if you want. When I do this, I get 4 root 3 as the area of one triangle. But I have 4 of them. They're congruent, so then their areas are congruent. So I just need to multiply this by 4. Remember, you only multiply outside numbers. So it's 16 square root 3. The reason why I said it's okay for decimals is because now when I do the area of the whole, I'm going to add 16 plus 16 square root 3. Now, if you want to be exact, you can just leave it like this and put units squared. Or you can type in the calculator and give me a decimal, which is 43.71 units squared. I will take either. Okay? Just as long as there's no pi in the problem, I will take a decimal. All right. That is it for these notes. Now, I know it's a little bit like a lot for today, but like as you read on Google Classroom,